evaluate this triple integral where T is the solid tetrahedron with vertices these four. So 0 0 0, that's the origin, 2 0 0 on the x-axis, 0 2 0 on the y-axis, and 0 0 2. So we have this T solid object, and if we look at its projection on the xy plane, just taking xy, so basically the bottom here, this is origin here, so it goes here, and this is 2 0 now instead of 2 0 0, and this is just 0 2, and this tetrahedron, its projection on xy plane is D here, so we got this triangular region, and we know the equation of this line. Okay, slope is -1, so rise over run, so it kind of falls, so slope is -1, and it has y-intercept 2, so y equals negative x plus 2. Okay, negative x plus 2 is the equation of this line. Now this triple integral, let's reduce into double integral and g in this way. This is same as double integral on this d, and we have bounds for g equals, and the function remains the same, dg, and we have the, in terms of area outside. Look at the bounds for g. It's the lower bound is on the xy plane, that means 0, g is 0, and up is just 2, 0 to 2. Okay, and we can easily evaluate this part. Let's continue working on. Now this d, this dA, we can write dy dx or dx dy, doesn't matter. Let me go dy dx. That means it's like type 1. If I write this type of going up arrow, then x runs from 0 to 2. Okay, so x runs from 0 to 2. The arrow can be taken anywhere, and y, lower curve x-axis means y equals 0, and upper curve y equals negative x plus 2. Y equals negative x plus 2 is same as 2 minus x, and we still have inside g 0 from 2, 3y squared dz. Okay, now this should be easy. We just evaluate this, then go outside, evaluate with y, then all the way to x. Okay, we could have written this as dx dy, then we had to change this. Then y would be, we had to take horizontal arrow, and y would be again 0 to 2, but x would be, this is 0 to this curve, which is x equals, by the way, 2 minus y. Okay, we can do that as well. Now let's evaluate this. Okay, it should be easy, and find the antiderivative of 3y squared with respect to g. This behaves like constant, so this is just 3y squared g, and we evaluate g from 0 to 2. Okay, and we have outside x from 0 to 2, y from 0 to 2 minus x, dy dx, replace g by 2 upper limit and lower limit 0, g equals 0 makes this thing 0, so there is no contribution from lower limit. So let me do the details here. So we have 2 3 6y squared minus 0, just 6y squared. Now we integrate with respect to y, that's 3y cubed. Now we need to evaluate upper limit minus lower limit. Okay, so that is 0 to 2 for x, 3 times 2 minus x cubed. Okay, that's the upper limit part. In fact, this 3 can be pulled all the way outside. Okay, and this is 0 cube minus 0 cube, not needed, dx. This 3 is outside. Let's integrate this. It's like power rule. So this is 2 minus x raised to 3 plus 1, 4 divided by 4, but x got -1, so we need to divide by that as well, and it goes from 0 to 2. Okay, let's just evaluate upper limit, lower limit. This is -4, we can pull outside, 3 over 4. upper limit x equals 2, 2 minus 2, 0 raised to 4, 0, minus 2 minus 0, 2, 2 raised to 4, 16, 3/4 negative 16, negative negative cancel, 4 goes 4 times 3, 12. That's final.